Some of the hardest problems in the world exist far above the planet. Our job? To launch the smartest solutions, to protect our satellites, clean up our clutter, to propel breakthroughs in propulsion, to learn more about our place in the universe, to outpace emerging threats. Every day, the Aerospace Corporation uses the latest technologies to ensure our nation's safety and leadership in space.
Welcome to the Space Policy Show. I'm here today with my co-host, Corbin Dallas. I think you remember him from last time. We've got Jim Vedda on today to talk about the history of the future of space, which is a very exciting topic. For those of you who are tuned in, you can ask questions two ways. You can either go on Twitter and send us questions by tagging them with hashtag the Space Policy Show, or you can comment in the box below the video and our experts will get back to you with answers. Just a quick bio on Dr. Jim Vedda. He's a senior policy analyst at the Center for Space Policy and Strategy at the Aerospace Corporation. Since joining aerospace in 2004, he has been responsible for performing policy research and analyses for various government customers, including NASA, FAA, Department of Commerce, the Air Force, and the NGA. So over to you, Jim. We're really excited to have you here today. Thanks again for joining us.
All right, thanks, Rebecca. In this session, we're going to talk about how we can go back to the past to look to the future of space. So space futurism is actually a very rich area, as illustrated by this stack of books that I have next to me, which are all about the future of humanity in space. So this is just what I have in my collection. There's actually a great library of things out there that go back well before the start of the space age. I'm going to focus on a certain subset of that, and not just because it's a fun intellectual exercise, but because there's something that we can learn from that to help us in our long-term strategic planning for space in our future. So what I'm going to focus on is a period of time that I like to call a golden age of space futurism. If I can have the first slide, please. And that golden age runs from the 1950s to the 1970s. And the reason that I call it a golden age is because this was the period in which the space visionaries actually were present at the time that space was emerging as a reality. They were watching it unfold. They were, in some cases, actively a part of making it happen. So this group of futurists, I think, was very inspirational to the activity that was going on and to a couple of generations of people, including myself, who then later became active in the space community. So what I'd like to do is look at just a few of the people that were putting forth their visions at that time and give you a sample of the types of things that they got right and what they didn't get right. But let's keep in mind throughout this whole discussion that it's not about accurately predicting the future. It's about trying to illustrate what a hoped for future would look like and maybe figuring out some of the steps of how to get from here to there. So if I could have the next slide, please. All right, these are the five guys that I'm going to focus on from the Golden Age, and you may recognize some of them immediately. I'm sorry if I didn't pick everybody's favorites. I know there are others on the list that were very important and don't appear here, like Willie Ley, Kraft Ericke, all great writers who inspired us. But I'm going to focus on these five, and starting with in the upper left corner, that's of course Arthur C. Clarke, the British writer, who was very famous both for his fiction and his nonfiction, and was credited with having the first scientific paper in a journal that described in detail how to implement geosynchronous communication satellites. That was in a 1945 edition of a journal called Wireless World. He continued to be a very active writer of both fiction and nonfiction throughout his life, and influenced a great many people along the way. Moving down to the lower left, that is Herman Kahn, best known for being a nuclear strategist back in the heart of the Cold War, and also for the founder of the Hudson Institute, which is a think tank that still exists today. In the middle, we see a picture of Jerry O'Neill, who was the professor of physics at Princeton, who was best known for his advocacy of space colonies. And we're talking about big space colonies, tens of thousands or even 1 million people on an orbiting space colony. And of course, one of their primary activities being the creation and operation of solar power satellites to serve Earth. In the upper right corner, Wernher von Braun, very recognizable character there. He was a German rocket engineer during World War II who came to the United States and then became the father of the Saturn V rocket and the head of the Marshall Space Flight Center. And lastly, in the lower right corner, Dandridge Cole, who is probably not quite as well known as the others on this page, but he wrote some fairly amazing stuff that is well worth reading even today. He was someone with a very diverse education. He had a bachelor's in chemistry, a master's in physics, and took some medical school training, and came out with some amazing books during the time that he was working. In part, one of the things he worked on was the development of the Titan II launch vehicle. Now, we probably would have seen a lot more out of Dandridge Cole, and he would have been a lot more famous had he not died so young. He, I believe, had some heart trouble, and he died at the age of 44 in 1965, but was up to that point a very productive guy. I had the privilege of meeting and interacting with two of the people on this page. I met Arthur C. Clarke in 1982 at a UN conference in Vienna. At the time, he was one of the delegates from the nation of Sri Lanka, where he spent the latter part of his life. And also Jerry O'Neill. I met him a couple of times in the mid 80s, around the time that he was serving on the National Commission on Space, and exchanged letters with him a couple of times as well. So I feel very close to the stories of the gentleman on this page here. All right, can we have the next slide, please? So in walking through the different ideas that were put forth by these 5 gentlemen, let's start with Wernher von Braun, because his ideas that were referred to since then as the von Braun paradigm were very influential, and that the familiar sequence that you see listed in the bullets on this chart are what he believed should be the progression of our movement out into space. So first we learn how to launch things from the Earth and operate satellites in Earth orbits. We follow that by sending humans into space. Then we develop reusable spacecraft, build permanent space stations, and after that, go and settle the moon, and next onto Mars. Now, what we've tried to do ever since this was put forward back in the early 1950s is to stay with that plan. And that plan is something that we took a little diversion from when we went to the moon before we actually built our space station. So we detoured a bit, but then we got back on the planet and have tried to stay with it. Interestingly, there were some very detailed designs, and I have a couple of models to show you here that indicate what was in mind for von Braun and his colleagues. You saw in those pictures that space plane that's up on the top of this rocket, and now this rocket will give you an indication of the scale that he had in mind for that launch vehicle to service low Earth orbit. Then moving on from that, the next thing he had in mind was space stations, and he was very serious about the size and capabilities of the space station. This is the model of what he had in mind back in the early 1950s. And as you can see, it's a It's a round or torus-shaped vehicle, so that was often referred to as the torus. But in building this model, I called mine ISS-2. So that was my choice of decal. So that gives you some idea of what he had in mind. So we've been trying ever since we finished the Apollo program to get back on track with the plan that Wernher von Braun had, and which you heard repeated in the George Bush Sr. administration, in which he proposed going back to the moon and onto Mars. 15 years later, when the younger George Bush proposed pretty much the same thing, and even more recently, everything has been trying to get back on track for the von Braun paradigm. So you can see how influential that has been over the years. If we can go back to the slide, I just want to point out from that. Let's go back, stay with the von Braun slide for just a little bit more. This was a very popular and inspirational thing back in the 1950s. As you can see, there's some issues of Collier's magazine that are showing space scenes on the front with the artwork of Chesley Bonestel. And there were 8 issues of Collier's over the period of 1954 to 56, which featured articles that describe humanity's future in space. And remember, this is the time even before Sputnik, so people were being primed for all of this. And it actually was all inspired by the book that you see in the upper left quadrant there, called Across the Space Frontier, which came out in 1952 and was written by a number of people, including von Braun and other colleagues, who each wrote a chapter in the book about different aspects of what they believed would be the future in space. It was amazing to read this and see some of the things where they were spot on, including a chapter on international space law, which pretty accurately described what later occurred in the United Nations in the 60s to adopt the Outer Space Treaty. Of course, they had their share of mistakes, and von Braun himself in this book was articulating his notion that it would be impossible to create and operate an Earth-launched anti-satellite weapon, a direct descent anti-satellite weapon. And the reason that he gave was because you could never make an electronic brain that would fit into a spacecraft that could do the job. You would also always have to have a piloted spacecraft in order to do a direct descent anti-satellite weapon. So that illustrates what happens when you fail to foresee the revolution in electronics that came not too long after that point, and allowed us to miniaturize everything. But still, fascinating to go back and see what they were thinking about, and how forward-looking they were even at that time. Can I have the next slide, please? Okay, let's go to Arthur C. Clarke. This was a book called Profiles of the Future, 1963. Now, Arthur Clarke was frequently releasing books that were actually compilations of essays that he had done for publications around the world. This one was no different. It was a collection of essays, but he tied them all together very well. And even at that early date, he accurately depicted direct-to-home satellite television. Now, remember, this is a couple of years before we had our first geostationary communication satellites, and already he's talking about direct-to-home television. Also, satellite phones, position location abilities built into the phones like we have today, and fax machines. He also talked about something that sounded very, very much like what we know today as the internet, in which people would electronically get their news and read their books and visit their libraries and download documents. So he was quite ahead of his time with this publication. The one thing I want to point out that's very interesting and even a little humorous is the thing that he put in the back of the book called Chart of the Future. And in putting this timeline in the back of the book, he advised his readers, don't take it too seriously. And that turns out to be really good advice, because the Chart of the Future timeline predicted nuclear rockets in the 1970s, planetary expeditions in the 1980s, artificial intelligence and fusion power in the 1990s, planetary colonization in the 2000s, weather control in the 2010s, and by the 2020s, interstellar probes. So very ambitious timeline, very interesting to look at, but he kind of missed the timing sequence pretty thoroughly on that. Can I have the next slide, please? A few years later, 1968, Arthur Clarke came out with another book called The Promise of Space. And I would suggest that even today, more than 50 years later, this would be a good book to give to somebody who is completely new to the issue of space and wants to know things like how do rockets work, how do orbits work, what's it like to try and travel around the solar system. The physics really hasn't changed much since 1968, so these things are still accurate. And it's very, very well explained here in language that any layman would understand how all of this comes together. So I think this is still a good book for people who are entering the space field and don't have any background in it. So the book also talked about reusable boosters, which is a big issue today, aerospace planes. And in the second bullet on this chart, there's the first part of it. I think he was pretty prescient about this. There would be truly commercial space transport being in sight by the end of the century. Okay, so by 2000, commercial space transport, and depending on how you want to define that, yes, we did get that. Commercial companies had space transportation capabilities that they were offering for sale by the end of the century, so that was right on. Then he said, and perhaps 50 years from now, in other words, 2018, anyone should be able to afford a visit to the moon at least once in his lifetime. I think we fell a little bit short of that. So checking my watch, I think we're a little past 2018, and we're a ways to go yet before people are going to visit the moon. Okay, next slide, please. This brings us to Dandridge Cole. Dandridge Cole was when he was already working in aerospace industry in 1953. He predicted that humans would land on the moon by 1970, and he seems to have nailed that one pretty well. One of the big things that he was enthused about was the capture, colonization, and mining of planetoids. And that was his word for asteroids. He didn't like the word asteroids for some reason. He preferred planetoids. He saw those as really the key to the solar system. So the two books that you see on here are Islands in Space, note the subtitle, The Challenge of the Planetoids. That's 1964. And Beyond Tomorrow, Next 50 Years in Space, that was 1965. And unfortunately, he died right after that book came out. What he foresaw in Beyond Tomorrow was that the next big thing in space after the moon would be exploitation of planetoids in the decade of 1975 to 85. So he also saw that space transport costs would drop by an order of magnitude every 7 years for the next 2 decades. Sadly, that did not happen, and I think we've seen plenty of evidence that did not occur, even though we wish that it would have. So advanced space vehicles with new forms of propulsion, extraterrestrial bases, these are all in the next 50 years from the mid-60s. So he's a very ambitious guy. And I like the quote that's on the bottom there where he says we could fill books with the problems of fundamental importance to the human race, which can be solved only by spaceflight, more easily by spaceflight, or more probably by spaceflight. So this was a a passion for him in which he went to great lengths to draw pictures of what the future of humanity in space would be, including how we would biologically adapt to living in space. Okay, let's go to the next slide, please. And this brings us to Herman Kahn. After he started the Hudson Institute in the mid-60s, he came out with a book called The Year 2000 in 1967. Well, back in those days, if you recall, every time you referred to the year 2000, you had to say the year 2000. Now we just say 2000. Yeah, remember 2000? Back then you had to say the year 2000. So that's what gave him the title of this book. And he mostly was looking at more general developments in technology and society. So space was not the primary focus of this book. And what I've listed here is the book contained a list of 100 very likely technical innovations. And I've extracted the ones that are relevant to space. So again, another place where we see the anticipation of direct broadcast satellites, direct-to-home TV, worldwide use of high-altitude cameras for mapping and so on. Of course, that was accurate. By 2000, we were doing that type of thing. Recoverable boosters. Well, recoverable boosters took a little longer to come along, but we were already thinking about how to do that in 2000, so not too far off. Space defense systems. Now, it's unclear exactly the extent to which he was describing particular things with this, because these lists didn't always have expansions on his complete thoughts of each bullet. Artificial moons and other methods for lighting large areas at night. Well, the Russians tried that a little bit, and we decided not to pursue such things. Permanent manned satellite and lunar installations and interplanetary travel. These were among the things that he thought were among the 100 very likely technical innovations by the year 2000. Now, if you could advance slide once, please. And here we see a list he had of 25 less likely possibilities. And I've extracted from that the ones that could be relevant to space, either through their technology or directly in space systems. Artificial intelligence, sustained fusion, not quite there yet. Room temperature superconductors, as far as I've heard, we're still working on that. Use of rockets for commercial or private transportation. Depending on how you define that, yeah, we did do that. Substantial manned lunar or planetary installations. No, not quite there yet. Planetary engineering. Again, this was not defined in a particular way to know exactly what they were driving at here. And my favorite one of the list is that last one, modification of the solar system. I wish he would have explained what he meant by that, because what, are we going to move asteroids around? Is that what he's talking about? Or are we going to trade some moons with Jupiter? Who knows? He didn't really specify what he meant by modification of the solar system. Now, I should point out that this is not the only thing that Herman Kahn and his colleagues put out related to the future of space. He actually put out, along with the Hudson Institute, another book in 1976 called The Next 200 Years. And it's one of the ones on this pile here. In that book, it was mainly an Earth-centric scenario that he was trying to draw, looking out 200 years. And then he took an aside at one point and said, okay, let's look at what we would do differently if there was expansive space exploration and exploitation. So he did consider that as an inevitable part of human activity in the coming 200 years, but did not get very specific about exactly how that would affect us. So next slide, please.
Jim, I have a question for you before you move on. So how
Sure.
did they define artificial intelligence back then? And have we achieved it? Or at least do you think we have?
Well, the artificial intelligence, the way I understand it, is the definition of it has been a moving target over the years as machines have gotten smarter or as software has gotten better. The things that a machine can do automatically, the things that a machine can do that today we call machine learning, that would have been considered artificial intelligence probably back in the 60s, 70s. But we've raised the bar since then. And we have said that machine learning is great stuff, but it does not necessarily mean that we have artificial intelligence. So that area has moved so quickly that that definitions change quite a lot. Back in the early days of computer programming, when people had to do very systems level programming and using very arcane techniques, when you came up with a language like Fortran or Pascal or something like that, some people referred to that as automatic programming because it was so much closer to the English language. Now we don't think of that as automatic programming anymore. So that is a quickly evolving area that would not be defined the same today as it was back then. And I do not have in front of me precisely the definition that would have been used back in 1967 by the folks at the Hudson Institute. Okay, let's move on to the next slide. Now, here's one that should be familiar to a lot of people, and certainly this was a big influence on me. Gerard K. O'Neill, 1976, came out with his book, The High Frontier. Now, what O'Neill had done was in his classes had asked the question of what is the most sensible place to settle for large human communities in space? And is it really a planetary surface? And what he came up with was that space colonies that could be designed more Earth-like would be a better choice. So he set out to show that the physics and the engineering were all understood at this point. And as he saw it, it was a matter of how much commitment and resources can we apply to these things. So he was always thinking along the lines of how can this be set up to benefit Earth, to improve the human condition. So he wanted to utilize the extraterrestrial materials, particularly from the moon, and also to create energy sources for the Earth, is particularly in the nature of solar power satellites that would beam power to the Earth. So this, in turn, of course, will preserve the Earth's environment and allow for enrichment of the of humans who were not only those working with the space colonies, but also bring more value added to the Earth. Now, he didn't like to predict particular years, like this is going to happen by 2000 or 2028. So, but he liked to estimate how long would it take once we really applied ourselves to it. Once we were completely committed to it, how long would it take? And he believed that, as noted here, he mentioned a high orbital facility could begin within 7 to 10 years from the mid-70s and be completed in 15 to 25 years. Well, as we know, O'Neill's ambitions did not move anywhere near as quickly as he had anticipated. But he did write another book where he looked even further ahead. In 1981, he came out with a book called 2081, appropriately looking 100 years into the future, where he delved more deeply into other areas such as what computers would be doing at that point, and automation and energy. But of course, space colonies were a big part of that. And in that book, he stated that by 2081, there may be more Americans in space colonies than there are in the United States. And a voyage of a few days to a space colony will be as commonplace in 2081 as a Caribbean cruise is to us today. Well, not precisely today, but just in general. So again, very ambitious. It's hard to imagine from our perspective today that in 2081 there's going to be more Americans in space than on land in the United States. But that was what he looked forward to, and inspired generations of people to look in the same direction. Notably, one who was inspired by him was Jeff Bezos, who founded Blue Origin. Jeff Bezos studied at Princeton, and he studied under Jerry O'Neill. So very close influence there. Next slide, please.
Great. Thanks, Jim. Were these mostly national or international initiatives?
Well, the concepts were described in ways that could use the particular technology that was available at the time. And if you're talking about the 60s and 70s, the best of the technology available was in the United States, and the most active program was NASA's, and we were still in a competition with the Soviet Union. So there was a nationalistic flavor to it, but there was also a recognition that this would be done internationally because it's a global effort to go and be colonizing the moon, for example, or to build space colonies that would become dominant parts of an Earth space economy. So yes, there was recognition of the international factor, but not as strong as it is today because it was still Cold War days. This last thing that I'll talk about as far as the predictions and comes from a publication called Current Events, and the Current Events newsletter is something I think in some form it still exists today, but this particular issue that you see on the screen here is from March 23rd, 1966, when I was in the 6th grade, and I received this issue. Now, Current Events was something that came out once a week, aimed at kids around 6th to 8th grade to explain to them, as the title indicates, what's going on in current events in language that a late elementary school student could understand. But this one week, they decided to do something a little different. And they decided to have this issue that was about what could be expected in 2000, which seemed like way the heck into the future because it was 34 years away and we were just kids. So this was not just stuff that was made up by the writers of the issue. They actually went out and interviewed people, and they quoted Arthur C. Clarke and talked about a variety of things: futuristic cities, as you can see from that picture, possibility of cities under the ocean. All of these were covered, but of course they covered space. And one of the things that they talked about in an article called "Life in Space Becomes Commonplace." Remember, this is by 2000. Life in space becomes commonplace. That we would have nuclear-powered rockets taking us into space. There would be orbital hotels, hospitals, universities, and maybe even space cities. That people would take 3-week vacations in space, and that we would have colonies on Mars. Now, that's pretty darn ambitious. And like I say, they were going to people who were real space futurists at the time, both scientists and science fiction writers and such, and they really saw a future moving that quickly. And immediately when I saw this issue, I was determined to save it until 2000 to see how we did. And we didn't quite match up to all of these things, but it was an interesting exercise to see what the ambitions were. By the way, one of the other things that was in this issue was the declaration that we would have a work week of no more than 4 days. You know, everybody would be working much less because there would be so much automation. There would be so many advances in computing that we wouldn't need to work for more than 4 days, maybe less than 4 days. And that one of our biggest concerns would be, what would we do with all of our leisure time? So I would really like to have that problem, but that's not exactly how it turned out. So, all right, so that was something from way back when in my childhood. Let's move on to the next slide. So At the Center for Space Policy and Strategy at the Aerospace Corporation, what we're supposed to be helping decision makers with is looking ahead and helping them have more access to considered options that are based on real data. And as has often been said, prediction is really difficult, especially when it's about the future. And the ways that the foresighting has generally faltered when compared with the actual run out of events is that it both underestimates and overestimates. For example, Arthur C. Clarke, brilliant as he was, and as much praise as he's gotten for being the father of geosynchronous satellites, he actually got the timeline very wrong. When he wrote his article in 1945 about geocomsats and how they could be done, he predicted that they would happen approximately 50 years in the future. In reality, they came about 20 years in the future. Now, how could he have gotten it so wrong? Well, in 1945, it was still 2 years before the invention of the transistor. And the integrated circuit didn't come along until sometime in the early to mid 50s. So he wasn't aware of those developments right around the corner. So he assumed that you were going to have to use vacuum tubes on the geosatellites, and therefore you'd have to have a crew that was constantly changing out vacuum tubes, which blew out very frequently. So these would have had to be crewed spaceships, and as a result, that would take longer. Well, didn't need to do it that way, so it happened actually faster than was conceived by Arthur Clarke. Also, the moon landings came along faster than a lot of people saw. There were some people predicting that our first moon landings wouldn't be until early in the 21st century. So in the predictions that underestimate, it seems that the technical factors, failure to see how quickly things might happen in the technology development, are the reasons why there is underestimation in some things. Okay, overestimation, usually in the form of predictions being off by many, many years, are mainly due to non-technical factors. And those being political, economic, and other societal factors that can change the trajectory of a technical development, which may move very quickly, but the enabling policy and law that allows it to be implemented may not move nearly as quickly. So the predictions that came from a lot of the visionaries of the early times did not even consider the political economic factors. They downplayed them or just ignored them completely. And in fact, I'm going to read you a quote from Arthur Clarke's 1963 book, Profiles of the Future, that we looked at a few minutes ago. And he came out right up front and admitted that he was just looking at the technical areas. He said, "I am limiting myself to a single aspect of the future. It's technology, not the society that will be based upon it. I also believe and hope that politics and economics will cease to be as important in the future as they have been in the past. Politics and economics are concerned with power and wealth, neither of which should be the primary, still less exclusive concern of full-grown men." So, with that sentiment, he was declaring clearly that he was following the technologies and what they could do. He was not saying this will happen and that the other factors didn't matter. So that's one of the things that we have to look at when we are doing our work to try and help policymakers, decision makers, and the general public that wants to understand these things, to look to the future in ways that make sense for making that future better. Can I have the next slide, please? All right, so decision makers are best served if they have something that prepares them for events that may happen. And as we're seeing now in the circumstances of the pandemic, this is one of the things that public policy needs to be prepared for. So nobody likes to be blindsided, and governments are expected to prepare for worst case scenarios. So that means some level of trying to anticipate the future is always warranted. So in cases other than just avoiding disasters, sometimes you want to target a particular outcome years down the road or avoid a particular outcome. And this may be substantially in the future. And if you want to target something, like we want this to happen by 2030, you have to anticipate what milestones along the way that we need to hit in order to make that happen. Now, one of the ways you can do that is by just tracking with the trends in particular industries, technologies, and such. Well, that's good to an extent, but it is not a complete study of how you should move forward, because it does not always take into consideration the economic and other societal, political considerations that can have very substantial effects on what happens. One of the main reasons that we went to the moon at the time we did, faster than a lot of people thought we would, was because politics forced that issue to develop faster. And then in the case of the post-Apollo era, politics and changing priorities in society forced the space program to slow down. So that was not driven by the technology, it was driven by everything else around it. So I always like to keep reminding people of the quote that you see at the bottom of this slide from Ed Cornish, who was the founder of the World Future Society, which got started back in the 1960s. In his book, he said, "The goal of futuring is not to predict the future, but to make it better." I think we should always keep that forefront of our minds as we try to do long-term strategic planning, that we should not try and write this off as, predictions that they're going to be wrong most of the time, so that's useless. Oh, strategic plan, that tends to be something that goes astray very quickly, so we don't need to do that. Well, yeah, we do need to do that, because we have to have a path to the desired future, and not a predicted future, but a desired future. Where do we want to be in X amount of time? What are the steps that we need to get there? And we are trying to be a part of that as we do our policy and strategy studies in our office, and with a new foresighting activity that's beginning there as well. Okay, next slide, please. So this kind of sums things up a bit for our considerations of our future in space, and also considering things like public polling. What does the rest of society want to do, considering that much of what we do in that area is coming from their tax dollars? The long-term space efforts should be linked to some kind of strategic goals at the national or the global level, so that their purpose resonates with the widest group of people. And as you've probably picked up by now, this has to be a multidisciplinary approach, because there are so many factors that affect how quickly space activities are implemented, what particular ones are chosen for focus. All of those variables, technical and non-technical, from space fields and non-space fields, all have to be considered. And of course, the one warning that's always there is be careful what you wish for, because you might get it. There are unintended consequences, unrealized expectations, things that could cause you to waste resources. So to give an example of things like geoengineering as a means to counteract climate change. Could be a possible solution, but it also could have second and third order effects that you didn't count on. So be careful what you wish for. All right, let's go to the next slide. Now, I want to finish the discussion with something about Maslow's hierarchy of needs. Now, you may have heard of this. It's actually been around a long time. Abraham Maslow created this in a series of papers across the 1940s and early 1950s, in which he was describing how we prioritize things in our lives. And of course, this has evolved since that time. This had criticism, but it actually has pretty good applicability in the case of a modern democratic society as to how we can think about people's needs and their prioritization. And this can be backed up by public opinion polls. So I like to look at this because it has relevance for how we talk to people outside of the space community about what we do inside the space community. So just to quickly tell you what these levels are all about in this pyramid of the hierarchy of needs. The bottom level, physiological needs. Now, this is the very basic stuff: food, water, air, sleep, shelter, the things that you die without, the things that have to be there routinely or else you're dead. So that's very basic. Next level up, the safety needs. Now, for an ancient cave dweller, you're probably talking about being confident that the pack of wolves is not going to come into your cave and eat you while you sleep. But talking in terms of modern society, what do we have at the safety needs level? That would be our health care, to make sure we're not sick all the time. Our law enforcement, to make sure that we're safe in our communities. Our national security, to make sure that we're safe on a larger scale. All of those things, they're always high priorities in public polling, and the reason, because they serve very basic needs. Next level up, social needs. This is where you bring in your family and friends and belonging, okay? And then the next level up, esteem needs, is where you talk about recognition and respect and self-confidence. Those are the things that we see up at that level. And then at the top of the pyramid, self-actualization. This is where we talk about truth, beauty, human destiny, spirituality, or in the terms of Douglas Adams, the author, life, the universe, and everything. So what we find is that we often pitch our information about space exploration and development very high on this pyramid, way up there, maybe all the way up to self-actualization. And one of the rules of Maslow's hierarchy is that you do not move up the pyramid until you've satisfactorily completed things at the lower levels. So you don't move from safety needs to social needs until your safety needs are satisfied to a considerable extent. You don't move up unless you're satisfied down below. So if you pitch the space program up at the self-actualization level and people aren't there yet, then it's not going to be relevant to them. We have seen that whenever polls are done of the space program, and the polls are exclusively about space, the vast majority of respondents, usually from 2/3 to 3/4 of respondents, will say, yeah, we think the space program is great. We think it's getting, it's good that it's getting this funding, or it should get even more funding. We like the space program overall. We like these particular programs, and everything looks great. But then if you take a poll in which space is put in a prioritization of an assortment of government programs, space tends to come out on the bottom. Why? Because space is not considered or perceived by many people to satisfy those lower level needs, the safety needs, the social needs. And as long as that's the case, it's going to be harder to reach large parts of the population to try and sell them on a pitch that really is up at the self-actualization level that they haven't reached yet. Now, you may look at this and say, okay, well then why did Apollo happen? How come we went ahead with the Apollo program even though that's too high level for most people? Well, one of the reasons we went with that was because it was brought down much further on the pyramid, all the way perhaps to the safety needs level, because it was considered something that was vital for national security. You had the NASA administrator and the Secretary of Defense at the time putting out statements saying that the space program was part of the fluid front of the Cold War. Now, that kind of rhetoric and the very obvious competition we were having with the Soviet Union at the time really brought the Apollo program and other space efforts down to a lower level like safety needs. But after the Apollo program was over and it achieved its objectives, then it was no longer at that level and it became something higher up. Now, those of us who work in the space community, we see ourselves satisfied at all of these levels because we get our paychecks from the space community. We have many of our friendships there. We have our esteem needs satisfied by the work that we do in the space community. And we may even achieve self-actualization because we're so overwhelmed by the joy of seeing the images that come down from the Hubble Space Telescope or the first images from a planetary probe. So that is something that it makes it hard for somebody in the space community to understand why others around the general public don't get it as much, don't appreciate it as much. And we have to look at this pyramid and remember we're not all in the same place at the same time, and consider that when we are discussing our strategic plans for future of humanity in space. And I think I'll just very quickly go to the last slide and mention that just about everything we've talked about here comes from my first book, which is called Choice, Not Fate: Shaping a Sustainable Future in the Space Age. So you can see the more complete write-ups of all the things I've been talking about today if you want to take a look at that book. And I'm pleased that we've had some time to talk about the past and how it influences the future.
Thank you so much, Jim. So I have a couple questions for you, but first, talk about self-actualization. You're one of the few rocket scientists that I know that is funding their saxophone playing with their day job. Or what you have a saying that you say? What is it that you say?
Oh, well, I usually say that my day job is simply to pay for my music habit. So yeah, there's there are different sides to life. You have to explore them all. So
to reach self-actualization, right?
Yes, creativity.
Honest, I have two actual serious questions for you. So who is your favorite contemporary author, or what's your favorite prediction related to space?
Oh, gee, I don't know quite how to answer that because I sample so many things that I hate to call any one of them favorite. I do believe that the something related to the O'Neill idea is that something I'd like to see played out into the future. Although I would broaden it a bit because O'Neill was very much fixated on the solar power satellites and how they would improve life on Earth. And in one of my letters to him, I suggested that, well, maybe his pitch would be stronger if he would broaden it out to things like space manufacturing and microgravity research and things like that. And he wrote back and said, no, I just don't see those things. It's got to be solar power satellites, So I think O'Neill was right about a lot of things, but I think he should have been looking broader, and that's how I would like to see the development of cislunar space. A very, very broad brush, industrial park type of approach.
Great, thank you. So my other question would be, it was really interesting to hear about Arthur C. Clarke. He wrote about international frameworks and treaties. How much did he influence the treaty? And do you know of any other examples?
Well, I wouldn't say that he necessarily influenced the treaties directly, but he did influence international thinking um, space development because Arthur Clarke was British, and he lived a very big chunk of his life in Sri Lanka, and he wrote for an audience of people that was all over the world, really. So his influence was more in internationalizing space rather than specific contributions to treaty principles.
Oh, yeah. Okay, great. I have one last question for you, and then I will let you go. But how is your tie collection faring in this time when you're not wearing ties? I mean, are they just
Well,
hanging all on the wall, or what are you? Or do you still
well,
put
see,
them
this
on
is the
sometimes?
difficulty when it comes time to go back to the office. I may not remember how to tie a necktie. It'll be so long since I've done that. But as you can see, I am not
Yeah.
growing a beard. That's not a part of my plan. But I am enjoying not constraining the oxygen flow to my brain through tight collars. But no, I have not thrown away the neckties. They are coming. They are coming back to the office someday.
That's great. For those of you who are watching, as a quick side note, the first time I met Jim, he was wearing a Star Wars tie. It was pretty awesome. He has a great collection. Well, thank you, Jim. We're so excited that you all could join us today. We're really fortunate to have you here. Our next episode is Outpacing the Threat with an Agile Space Enterprise with Karen Jones, David Eccles, and Melina Hills. So until then, check us out. We're on aerospace.org/policy. Get the latest news and alerts, and we look forward to seeing you here soon.